Oh, so this is my attempt to slowly explain both versions of the exam. So version A says electron configuration of 282. And then version B says 2881. So the easiest way of doing these is just using the reference table. That's the wrong one. So using a reference table to find these elements. So the first one said 2881. 881. So if you just add those numbers up, that equals 19. So we find number 19. You see, oh, number 19 is potassium. Okay, so that's why the answer for that was potassium. And the next one is 282. So 2 plus 8 plus 2 is 12. And that's magnesium. So when you see questions like that, just add them up together, and that will be the corresponding element. Right, so going back to the next one. Sorry about this. Computer. All right, so next one. The modern model of the atom shows that electrons are. Okay, so the modern model had probable paths in orbitals. Okay, it's not this because that's the Bohr model. Right? The Bohr model is not the same as the modern. The modern model had regions called orbitals. And that was the same question on both exams. Let me show that to you in the notes here. So the modern model, and this is standard 1.1, right? Over a long period of time. Where is it in the notes? It's right here. So the modern model or wave mechanical model, electrons are in probable locations called orbitals. If we got that one wrong, look at number 5 in the condensed notes. Make a flashcard to help you out. The next one here, which subatomic particle has no charge? Okay, it was the same question on both exams. So where is that in the notes? It's actually in a lot of places in the notes. But really quickly, a subatomic particle with no charge is a neutron. Right, that was on page 12 of your notes. Okay, next one. How many electrons are an aluminum positive 3 ion? Okay, what does that mean? So first find it as an atom. Right? When you see the word, you look with your eyes, you see the word atom, your brain should know and hear that protons equals electrons every time. When you see the word ion, your brain should say, oh, protons do not equal electrons. So if they do not equal, is it more or less? When you see a positive charge, it is less electrons. You see a negative charge, it's more. So let's go to aluminum on the reference table and see how much it is as an atom first. Right? Let's go to our reference table. Let's find aluminum. Right? So you should be familiar with the location of these here. Aluminum is number 13. So as an atom, it's 13 protons and 13 electrons. As an ion, if it's positive, you subtract 3. So instead of having 13, it has 10. Okay. Why is that? Because when you lose a negative number, that's a positive. 0 minus negative 3 is 0 plus 3. Okay, so let me show you where that is in the notes. Here. So it should be in the condensed version. But look at number 9A and 9B. Protons minus electrons is the charge. Okay, so that said, if the charge is positive 3, protons minus electrons equals charge of an ion. In the question, it's a positive 3. You know protons is 13 because you looked on the reference table for aluminum. Let me make this more clear. And aluminum has 13 protons because the atomic number tells you the protons. And aluminum's protons is always 13. Okay, so 13, going back to this here. So 13 protons minus 10 electrons will give you a charge of +3. You must know this formula for charge. Protons minus electrons is charge. If you don't know that, the ionic questions will be tough to understand. Right, so going on to the other version, version A. This one says O -2. Right? So it says O -2, that means you have to add electrons, right? So let's find oxygen. Let me clear this here. We find oxygen for you. So there. Now, if I look at the reference table for oxygen, I see that it's number 8. So as an atom, it has 8 here. Right? Atomic number is protons. So as an atom, it has 8 protons and 8 electrons. Now, as an ion, what does the negative mean? Well, as a -2 charge, don't forget the formula in your notes. So what do I know about oxygen? Well, I know protons minus electrons is a charge of an ion. Okay, so let me clear the screen. So the protons minus electrons is the charge, and the charge given was -2. The protons are always the atomic number. 8 minus x equals -2. How do I solve for x? Well, I have to get it to one side, or I could just use a calculator, but I can, to get rid of this, just add 2 here and add 2 here. Would that even work? Let's see. 10 minus x equals 0. And then 10 minus 10 equals 0. There's many ways of doing that. I actually hate doing this way, but x is 10. So going back to the question, how many electrons does it have? So back here, it has 10 electrons, right? So 8 minus 10 gave me a -2 charge, right? That's the charge on top, -2. Right? So I got that one wrong. I'm hoping it's a little more clear. And again, for aluminum, its protons was 13, and 13 minus 10 gave you a +3 charge. Okay, so whenever you're doing ions and finding the electrons, please use the formula protons minus electrons equals charge. Right? So don't forget that. Okay, isotopes. For question 5, it's the same protons and different neutrons, or you could say same atomic number and different mass number, but both versions are basically the same. So where do we find out information about isotopes? Well, it's in the standard. So let me show that to you really quick. Really slowly. It's on page 9. So what are isotopes? What those mean? Okay. So isotopes, have the same protons and different neutrons. So where does it say that? Atoms of an element that contains the same number of protons but a different number of neutrons are called isotopes of that element. Now you have to ask yourself, well, how do I know which ones are the protons, which ones are electrons? If you look at your notes again, so the theme here is read the notes, review the notes, don't rely on just memorization the night before. You have to look at it every day. Okay, so in writing an isotopic notation, the mass is on top and the atomic number is on the bottom. So which of these formulas had the same bottom number but different top number? Let's go back to the test and see. So, the same bottom number and different top number is choice 3 here. And then version B, it is choice 1, because the bottom number is the atomic number and the top number is the atomic mass. Okay. So that's the first 5 questions. I'll let you process that and I'll make another video for the next 5. Thanks for watching.